Good morning. In the last class, we have covered three methods of root finding, namely the method of incremental search, method of fixed point iteration, and then we have seen about bisection method. So, we know the method. Now, I will take one example, simple example, and I will show 1-2 iterations how it goes. Okay? Let us take the same example that we took in the previous method. We are doing here bisection method, where we will take fx as 4.905 x square minus 15x plus 5 is equal to 0. The same problem I have solved using fixed point method of that fixed point iteration. Okay? Now, we know that initial guess we have obtained as x belongs to 0.3, 0.4. This we have obtained by what method? Method of incremental search. So, the root lies in this interval 0.3 and 0.4. That means f of 0.3 and f of 0.4 have different signs. So, that I will have f of 0.3 into f of 0.4 will be less than 0. Fine. Now, as per this bisection method, I will take first this a as 0.3, b as 0.4. Then I will find P1 as a plus b minus a by 2, a plus b minus a by 2, and if I put a and b, this 0.3 and 0.4, so what we will get? 0.35. This is actually a plus b by 2, but I will write a plus b minus a by 2, and this is 0.35. Okay, P1, first iterative value from the initial interval a and b. Now, I will check for this sign of this fp1. So, fp1 will come out to be f 0.35. So, I will put this 0.35 here for x, and this will be 0.3509, which is positive. We now know that root will lie between 0.35 and 4 because 0.4 because 0.3 was positive. Okay? Now, 0.35 is more closer to 0.4. So, root lies between now x belongs to 0.35 and 0.4. Now, again I redefine the a and b as we discussed earlier. I will write a nu as 0.35, b nu as 0.4. Fine. And then I will find P2 as a nu plus b nu minus a nu by 2. So, if I put these values 0.35 and 4 respectively for a nu and b nu, I will get the value of P2, and this P2 comes out to be 0.375. 0.375. Again, I will find fp2, and I will check the sign of this function fp2. fp2 will be 0.0648. This is again positive. So, now the root will lie in the interval 0.375 and 0.4. Fine. So, now x should lie in 0.375 and 0.4. Again, I will redefine a nu and b nu, and I will proceed till I get the desired accuracy. Fine. Desired accuracy means I will find epsilon r. Suppose at this iteration I want to find relative error. So, relative error will be what? I will take this 0.375 as the best one. Okay? 0.375 minus 0.35 previous iterative value divided by 0.375. So, this will be your, after computation, the relative error between the two iterations. Okay? You can see one thing more, that you see here it was 0.35, here 0.375. So, one digit has converged after two iterations. So, if you go on like this, find P3, P4, etc. So, you will see that it should converge. Okay? And it depends upon this accuracy also as per your desired problem. So, this is your bisection method. So, bisection method, what you will do? I will find AB, the interval, then find PI's P1, P2, P3 as per this formula, okay, and check the sign of FPI's and FB. Okay. So, those signs, after seeing that, we will find the intervals and slowly it will converge. So, that is your bisection method. Okay. Let us now come to the next method, that is method of false position. Next method is method of false position, or sometimes it is also called regula falsi method. Regula falsi method. So, this was our fourth method as per our sequence, that sixth method I had written in the last class. So, in this method, what we will do, you see I have the plot of x and fx. Suppose this is your plot for the function fx given. You remember, I am always taking this fx equal to 0 and fx is continuous. Okay? So, suppose this is the fx and I have found a and b where the sign of fa and fb are changing. That means I have fa into fb less than 0. Fine. This I can find by the first method, that is method of incremental search. So, now I will join this line. Join means to know that this is fa and this is fb. Now, this point and this point I will join. Fine. This is cutting here, the x axis. I will take this as P1. Okay? Now, where it cuts, again I will draw a vertical line here touching this curve. Then from here again I will draw a line like this, it is cutting here. Understood? Again I will draw a vertical line on this curve, I will join this, it is cutting here. So, like that I will proceed and it should reach to this root that we want. That is the procedure geometrically. Okay? Now, I will derive the formula to get these points. That is your method of regula falsi or false position. Now, I have this curve like this. This is your A, this is your B. Now, I told you will join this. Okay, fine. It is cutting here and our root is this. So, now this is P1, this is your FA and it will be negative as per this plot. If it is like this, so it will be here FA, okay? Or so this is FB. Now see these two triangles, this and this. These two triangles are similar. Okay, you know, if these two triangles are similar, I can have the ratios of these sides. Okay, equality of that. Okay, so I can write P1 minus A by minus FA is equal to B minus P1 by FB. From these two triangles, I am writing this ratio. Is it fine? From here, see, our aim is to find P1. Okay? So I can solve this, and if you solve this, you will get P1 cross multiply, and then find P1, you will get AFB minus BFA by FB minus FA. Understood? So this becomes the formula for getting P1. P1. After simplifying this, you can check, I will get AB minus BFA by FB minus FA, where I know A, B, FA and FB. So I can find P1. This will be minus FA, because it is in the negative side, otherwise it will not get this. Okay? So now P1, after getting this, I will check the sign of P1, sign of this. So if this sign is positive, that means root will lie between P1 and B. Okay? So I have to again define P1 as A in the next iteration, P1 as A and B I have B. Then I will find P2. Redefine that AB, I will apply the same formula, I will find the P2. Again I will check P2 and FP2 and FB. Okay? So slowly it will come to here, this root. So this is the procedure for this regular falsy method. Fine? So let us take one example. So example, let us say we are given fx is equal to e to the power x minus 2x square is equal to 0. Find a root x greater than 0 Okay, this is the problem. So what we will do? I need to have the interval, guess interval, where FA and FB changes sign, different sign I get. So again I will apply what? Method of incremental search. Method of incremental search. So if x and fx, I will start from 0 and I will take suppose delta x as 0.5. Delta x as 0.5. So 0, 0.5, 1, 1.5, 2.0, like that. I want the f values for these x. So if you find, you will see that at 1, here you will get positive 0.718 and here you will get minus 0.018. So sign is changing from 1 to 1.5. So our A is 1 and B is 1.5. Fine? So this you have to find by method of incremental search, or for the exam purpose of B purpose, you should be given then A and B. Okay? The interval where the sign is changing. So now use that formula P1 AFB minus BFA by FB minus FA. So I need here FA is equal to 0.718, FB is minus 0.018. So these you put in that formula. P1 is equal to A FB minus B FA by FB minus FA. Okay, fine, just substitute that, these values. So, you will get P1 as 1.4876. Okay, after the substitution of those values A, B, FA and FB. Now, I have to find FP1. This is your 0.00055. So, you can see this is having positive sign. Okay? So, again I can redefine this as nu, or you can write A also if you are not confusing. I am using nu because so that you know that this is nu A you are getting. Okay? So, nu will be what? 1.4876, B nu as 1.5, 1.5, and then again find P2. Again here A nu into FB nu minus B nu into B nu of F of nu, then divided by FB nu minus Fa nu. Okay, so these values you will substitute there. So, you will get P2 as 1.48796. 1.48796. Fine. So, now you can see I was having FP1 as 1.487. If I chop after 3 decimal, if I chop here, you are getting 1.487. So, see, 4 significant digits are matching. Okay? So, convergency here I get better by chance. Okay? 2 iterations I am getting 4 significant digit convergency. Again I can find the error epsilon r is equal to P2 minus P1 by P2. And this comes out to be 0.000. Understood? So, at each iteration I can find the relative error and I will take the current one as the best and the previous one as the approximate. So, P2 minus P1 by P2. So, if P1 and P2 are exactly equal, what we will get? Relative error as 0. That means exactly you have found the root, but in computer in general you will never get 0. Okay? If you have the real numbers here, means this type of function or real number. If exactly integer, some equations you may get, depends upon the problem. Okay? But that is why these errors are very important. What error you want, with what accuracy you want the solution, okay, or with what significant digit the result you want for this root. Okay? So, in this way you can proceed till your desired accuracy P1, P2, P3, P4, etc., and so that you will get the convergency as per your requirement. So, this was your regular falsy method. See, whatever methods we are doing, whether it is bisection, regular falsy, or next method I will do, that is, what is that method? NewtonRaphson method. Okay? So, these all methods are having their own limitations. That is why we have different methods. Understood? So, we will see the rate of convergency, etc. Means which method gives you faster convergency. You have seen you can solve this by other methods. See, procedure, you take one problem and solve by all the 5 methods. You see which one is faster, but we have some theorems that tells that which method is of what rate of convergency or order of convergency, how fast it is converging. So, next method I am going to do is NewtonRaphson method, and in general that is very powerful method. You will see though that method is having quadratically convergent. Okay? So, and there are having some limitation, that also we will do in the maybe next class. Okay? This method slowly. Okay. So, come to the next method, that is called NewtonRaphson method. Fifth is Newton-Raphson method, or sometimes in some of the books it is written as Newton's method, simply Newton's method. Okay? So here again geometrically first I am showing that how the root we get. Okay? So again I will take the plot of f(x) like this maybe, fine, where I have the, suppose, or let us take xi. Xi means I can put I equal to 0. So first guess value you have from your first method, or it is given. Okay? So I have xi, I want to know what is the next iterative value. Okay? So here in Newton-Raphson method, what is there? I will draw a tangent here at this point. So what is this? This is your f of xi. And suppose this tangent makes an angle phi here with positive x axis. Fine. I will take the guess value, draw a vertical line touching to the curve, then draw a tangent. That tangent makes an angle with the x as phi. Fine. So this phi, if I want tan phi, will be what? And I suppose that this is your next iterative value because it is touching xi plus 1. Okay, fine. So tan phi will be this by this. Okay. So this is how much? F of xi, and this is your xi minus xi plus 1. Moreover, what is this tan phi? It is the derivative at this point. For this, the derivative means the derivative of xi. That means this is what? F dash xi. Is it correct? F dash xi. So now I have f dash xi is equal to this. Okay? So if I cross multiply, so what we will get? Xi plus 1 is equal to xi minus f of xi by f dash xi. So you see, if I put I equal to 0, so what you will get? For I equal to 0, x1 is your x naught minus f x naught by f dash x naught. That means what are the things needed to, this is your first iterative value x1. So to get x1 I need x naught, I need fx, and I need to get the first derivative of fx, that is f dash x, and then I will put x equal to x naught. Okay? So these things I need to get the first value. So what is here happening? See, I want the next one geometrically. So again I will draw a vertical line touching this curve. Again I find this tangent. Again find this phi. This again vertical line, again the tangent. So slowly it will reach to the root. That is the iteration is going on. Okay? So now you see, that means this derivative I have to find. So again fx is complicated, or I cannot find the derivative, then I have problems. So I told there are limitations. So that is why I have the next method. But anyway, if I can find derivative, so this method practically people are using this Newton-Raphson method. This is quadratically convergent, that we will prove by theorem that this method is quadratically convergent. Okay? So let us take one example. So this method, this derivative, and also see whatever method I am doing till now, I am beautifully taking like this function or this, but in actual case you may not have like this. Okay? So then there may be some problems, so those things I will discuss later. Okay? Because if you think that this is the root, it may suit to some other, because it is, see, one cutting means one root is there. I can have other function like this, maybe like this. So, I have two roots. Okay. So, how to find that? And sometimes it may fail also, because you are targeting this root, it may go to the here, because you will see if I draw tangent, again vertical line, again phi, so it may go to some other place. So, those are the limitations, function should be continuous, etc. are there. Okay. So, let us take one example for this. I have x cube is equal to 20. I want to find the root, one root. Find one root, suppose. And it is given that x naught is 3.0. X cube is equal to 20 means cube root of x, or not, that you know although the result, but let us find by the Newton-Raphson method of this root. Okay. So, what is our function? Fx is x cube minus 20 is equal to 0, because I have to write the function in terms of fx equal to 0. Fine. So, I have fx, I have to find f dash x, that is 3x square. Now, I will apply for first one, that is x1 is equal to x naught minus fx naught by f dash x naught. X naught given as 3.0 minus fx naught, that means fx naught will be what? Fx naught will be 3 cube minus 27. Sorry, this is not the way. X naught is 3.0 minus 7 by 3x naught square, that means 3 into 3 square, no? And this will get, I think this will get 2.741. Means you will put x naught, here fx naught means x naught cube minus 20 and 3x naught square. Fine. So, you will get that. Next iteration x2 is x1 minus fx1 by f dash x naught. Sorry, f dash x 1, all are 1. So, now x1 is your, so let me write first x1 minus fx1 means x1 cube minus 20 by 3x1 square. Substitute this x1 2.741 here, x1 value 2.741. So, you will get this value as 2.715. Now, the relative error epsilon r I can find as absolute value of x2 minus x1 by x2. Substitute those values of x1 and x2, I will get the relative error as 0.96 into 10 to the power minus 2. Fine. After getting x2, I can find x3, that means x2 minus f of x2 by f dash x2. So, this you will get 2.714. So, this is your x3. Now, if I want to find epsilon r at this iteration, it is x3 minus x2 absolute value by x3, and this will comes out to be 3.68 into 10 to the power minus 4, 10 to the power minus 4. So, you can see the convergency. See, in the second iteration x2 what you are getting 2.715. Third iteration you are getting 2.71. So 3 significant digits are converging after third iteration. You can check the error also. See, error here is 0.96 into 10 to the power minus 2. It is jumped to 10 to the power minus 4. Okay, so that is the cause. Actually it is quadratically convergent. So each iteration you will get like this jump. Okay, so again it depends upon the problem, although problem means this plotting, how you get the plot. Okay, so there are conditions upon which this will converge to like this, quadratically convergent. Okay, so very simple method. Just find the given fx. From fx it is, you find the first derivative, use this formula, xi plus 1 is equal to xi minus fxi by f dash xi. Okay, so you put that, you go on as per your desired accuracy. That is your NewtonRaphson method. Let us prove this. Newton means derive this formula by Taylor series method, because you see Taylor series is very important with respect to numerical analysis. What we will do, see, I can have the Taylor series of fxi plus h. What is the Taylor series of this with respect to h? Fxi plus h, that is your f of xi plus h f dash xi plus h square by factorial 2 f double dash xi and other terms. Okay, this you know, this Taylor series. Fine. So I will then now this, in this Taylor series I will truncate here after second term. Okay, and xi plus h is your xi plus 1 minus xi. The distance between xi plus 1 and xi means x1 and x2. Okay, so now, so that means I suppose that this is your exact value in some iterations. Fxi means it satisfies the given equation. So approximately this will be what? If it satisfies the equation, certain point, so it will be what? Suppose I have fx is equal to 0 given equation, fx equal to 0, I have found s as the root. What will be f of s? Should be 0. That's I am telling that if this is the at sub iteration you are getting the exact value here approximately. So what will be this value? 0. So this is 0 and this is approximated, I have also truncated there. So what we will get? Remaining one fxy plus h into f dash xi. Fine. Now this 0 I will just put equality to get the formula fxi, and I told that these all methods are approximated. Okay. So I am converting this to equality, and h is your what? xi plus 1 minus xi f dash xi. Now simplify this, you will get the same formula xi plus 1 is equal to xi minus f of xi by f dash xi. So this I can derive from the Taylor series. Is it fine? So same. So one method left, that is called secant method. Okay, that we will do in the next class. That is the last one is secant method. So the name is secant means, so here I am just giving you an idea that here see, in the NewtonRaphson method I draw a tangent from here. So here in the secant method I draw a secant where this cuts at two places on the curve. So using these two I will iterate. I will derive the formula okay, and there only you will see that there I need not to find the derivative, because derivative is again depends upon if you have the complicated function. So, derivative takes time, okay, because I told in earlier classes that if you have this f x is complicated, e to the power x cos hyperbole x whole to the power ln x, like that something. So, derivative itself requires time and procedure. So, if you do not have to find a derivative, so then you can go to the second method, where you did not to find the derivative directly, okay. There only the x naught values if you put, you will get the some function, and then we can find, we can have the formula, but you need 2 points to start. If you see here in the Newton-Raphson method, we need only 1 point to start, that is x naught. There I need 2 points, because I am telling 2 points cutting. So, 2 points I will need here and here, okay. So, 2 points I will need, and then it can approach to the root, that is your second method, okay. But the convergency rate is slower than the Newton-Raphson, okay. So, I hope this is fine with this Newton-Raphson method. Then we did method of regular falsy, then previously then bisection, method of incremental search, and fixed point iteration, okay. So, in the next class we will do the second method and maybe the convergency of Newton-Raphson and second method, okay. Thank you.